This video is on a subject called molarity, which is another mole relationship. And when we start, we need to start with some definitions. We'll be talking about solutions, which is a homogeneous mixture in liquid form. There is the solute, that which is dissolved. There is the solvent, that which does the dissolving. And an aqueous solution, which is written as AQ in parentheses, is a mixture in which the solvent is water. So if I take table salt, sodium chloride, and dissolve it in water, the table salt or sodium chloride is the solute, the water is the solvent, and because the solvent is water, we would say that it's an aqueous solution of sodium chloride. Molarity, which is abbreviated capital M, is a ratio of solute to solution, otherwise known as concentration. Molarity is defined as the moles of the solute divided by the liters of solution, sometimes abbreviated as moles over liters. There are three variables here: molarity, moles, and liters. So if I know any two of those variables, I can calculate the third. So there are two rearrangements. Moles times liter equals molarity, and liters equals moles divided by molarity. These brackets here, this one and this one, when a chemical is written in the brackets, it means you're talking about concentration of the chemical or the molarity of that chemical. So the best thing to do is jump right in with examples. We have 3 examples coming up. I'm going to have you do them, then I will give you the answers, and we will walk through how we got the answers. So start with, you have 0.225 moles of acetone, and it's mixed with water to make 3/4 of a liter of solution. What is the molarity? Go. And the correct answer is 0.300 molar. How did we get the answer? Well, we're given the number of moles of acetone and the volume of the solution in liters. We're looking for the molarity. The equation for molarity is moles divided by liters. So I substitute in where appropriate. There's no need for rearrangement, so I can easily solve it, and I get 0.300 molar. On to the next example. What is the final volume in milliliters of a solution of 1.35 molar sodium hydroxide if the sample has 0.625 moles of sodium hydroxide? Stop, get your answer, come back, check it, and we'll go through it. Go. And the correct answer is 463 milliliters. We're given the molarity, 1.35 molar. We are given the moles, 0.625 moles. We don't know the volume of the solution. We do know that molarity equals moles divided by liters. Plug in the values, substitute them, rearrange it so you can solve it, and you get 0.463 liters. But the question asks for milliliters. But there are 1,000 milliliters in 1 liter, and notice the liters will cancel out here, and that's how we got 463 milliliters. So one more example. You've got fructose, C6H12O6. You want to make 350 milliliters of a 0.1250 molar solution. How many grams of fructose do I need? Stop, figure it out, come back, check your answer, we'll go through it. Go. And the answer is 7.882 grams. We're given molarity. We're given the volume in milliliters, but for the molarity equations, it needs to be in liters. So we convert to 0.3500 liters. We're looking for the grams of fructose, and there is no equation that relates these things to grams. So we're going to need multiple steps. We know of 3 equations that involve moles. We know that molarity equals moles divided by liters, moles times molecular weight equals grams, and mole times 6.022 times 10 to the 23rd molecules per mole equal the number of molecules. And nowhere in the question do we mention the number of molecules, so that equation is not needed. So we're going to be using the remaining 2 equations. With the information that we have right now, molarity and liters, we're going to want to start with this equation And the reason being is moles is common to both equations. So once I figure this out, I can plug it in over here. So my unknown changes to moles of fructose, and my equation becomes molarity equals moles divided by liters. I substitute in my values, I rearrange, and I realize that I need 0.04375 moles of fructose. So now I've got, as my givens, the number of moles of fructose, and I can calculate the molecular weight of fructose, which is 180.16 grams per mole. I'm going to be looking for the number of grams. Go back to my second equation, moles times molecular weight equals grams. Substitute in my values. There's no need to rearrange, and I get 7.882 grams. So to review, molarity is a quantification of the concentration of a homogeneous mixture called a solution. It is the ratio of number of moles of solute compared to the volume of the solution. The equation is molarity equals moles divided by liters, and as there are three possible variables, if you know any two, you can calculate the third. To go from molarity to grams requires 2 steps. To go from grams to molarity requires 2 steps. To go from molarity to number of particles requires 2 steps. To go from number of particles to molarity requires 2 steps. And then just to remind you, to go from grams to number of particles requires 2 steps. To go from number of particles to grams requires 2 steps. And so here is a basic roadmap that shows you how to go from grams to moles, molarity to moles, or number of things to moles. Notice mole is the central character in all of these. And there are the 3 basic equations. So now you have 3 ways of dealing with the mole. Later in the course, we're going to add a 4th, but right now you need to go practice a new set of mole conversions.